Hey, it's Mr. N again, and here is our in-class Chapter 5. This is for Test 1. This is for Test 1 from 5.1 to 5.3 review. Another of the multiple reviews that you've gotten. So, for this first question, on the other video and the other review sheets, you've had one similar. I'll try to explain a little bit different on this one, though. Here, we are asked to find the second derivative. This is the first derivative, and then I take the derivative again. This would end up being the second derivative right there. So on the other one, I said, well, you could think of it as the x going into this one. On this one, well, I need to know what this derivative is in order to take that derivative. So that's just another way of thinking about it. Again, there's more than one way to do it. So basically what we want to do here is we're going to take this t and apply the fundamental theorem of calculus, so FTC to it, and we're going to plug it in here and here, but don't forget the chain rule. So we are going to multiply this by 3t squared as we continue on because we are applying the chain rule. Then once we get that answer, we're going to take this x and put x into that answer, and again apply the chain rule, but the derivative of this x is just 1. So that second part of it is not going to be that big of a problem. So f prime ends up being 5 plus, let's go ahead and say this is t cubed squared over the t cubed times the 3t squared. So cleaning this up, this ends up being 5 plus t to the 6th all over t times 3. So that means f double prime, we're just going to put in the x that we see right here into that, and we end up with f double prime as being 5 plus x to the 6th over x times 3. And we need to plug in the value of 3 because that's what we're looking for. So go ahead and do that. So f double prime of 3 ends up being 5 plus 3 to the 6th over 3 times 3, which comes out to be 734. Okay, moving on to number 2. So for number 2, we've got this graph. It consists of 5 line segments, a semicircle, and a quarter circle. Let g be the function given by that integral. So, since we've got that integral, look at the starting point. We're starting here at 2, not at 0. So we are starting at this point right there. Again, starting at 2. So it's from 2 to x. So we're going in that direction or this direction, whatever x is. And we'll adjust it to whatever value we end up with for x. So for this first one, if we are asked to find g of negative 5 right here in part A, what I'm looking for is the area under the curve. But look at what g of x is. G of x is this integral that we have right there. So let me substitute the value for x, because that's my x, into that part of the integral. So this ends up being from 2 to negative 5 of f of t dt. And again, this is f of t, this function that they gave me. So here, notice the bounds go from 2 to negative 5. So we need to switch that. We can switch that to be g of x is going to be the integral from negative 5 to 2 of f of t dt, but since we switched it, we need to put that negative right out in front there. So whenever you switch the bounds, we can change it to make it equivalent by putting a negative on the outside because we're just going in a different direction. So this problem is basically asking me to find the area under the curve from 2 to negative 5. So from here to here. Well, let's find the area under the curve for each of these pieces anyway. It's just going to make the problem easier later because we might end up having to do that eventually. So what I want to do is I want to find the area of this triangle right here first. Okay, well, the area of that, it has a base of 2 and a height of 2. So the area of a triangle is 1/2 times the base times the height. But be careful, this is a negative 2. You can also think of it as it's below the axis. It's a negative area. So this will be 1/2 times 2 times negative 2, which will give me negative 2. So this has an area of negative 2, and it should be negative because, again, this area right there is below the axis. Okay, let's find this one right here for this triangle. For this triangle, it has a base of negative 5 and a height of 2. So 1/2 times the base times the height gives me 5. Find the area of this triangle right in here. This comes out to be negative 1. Find the area of this rectangle. This comes out to be negative 4. So 2 times 2. And again, below the axis, that's why it's negative. So again, what I'm doing is I'm going through and finding all these little areas first of each of these little segment parts. It'll kind of make the problem easier later as we see what's being asked. Let's do this quarter circle right here. This is a quarter circle. So a circle is, the area of a circle is going to be pi times the radius squared, but since this is a quarter circle, we need 1/4 of that. Well, this radius is 1, 2, 3. So 1/4 times pi times 3 squared, which gives me 9/4 pi. So this area is 9/4 pi. All right, we can find this triangle in there. That comes out to be negative 1. And now we're left with the most difficult piece of all. We've got this region in here. Well, if this is a semicircle and this piece is a rectangle, we're just going to say the rectangle minus this semicircle gives me what's left over in here. So let's go ahead and do that. So this ends up being, the rectangle is going to be 4. So it's 2 by 2. So the rectangle is 4. This is going to be 1/2 times the radius of 1 squared times pi. So I end up with 4 minus pi over 2 for that area. And this is a negative. So let's go ahead and make sure we indicate that this is a negative value because it's below the axes. Let me see if I can rewrite that a little bit better. Okay, so let's just make sure, we'll do it in another color, that we indicate that this area here is negative 4 minus pi over 2. We need that negative there. All right, so let's take a look at what we have to do. I'm going to slide this up a little bit. So for the first one, we said that we need to find g of negative 5, so we changed this to be the integral. So g of negative 5 ends up being negative, the integral from negative 5 to 2 of f of t dt, which ends up being negative. Now, I need the area from here, let me use the laser, from here to there. So I need both of those areas. So this is going to be the negative 2 plus the 5. So this is the negative 2 plus the 5. But remember, you're going in a backwards direction here because we have our negative. We flipped the integral around already. So it's already been taken into account for. The signs have been taken into account for because we've already flipped this integral. So that's why you have the negative on the outside. And now you're just adding this area and that area. So that gives me 3 inside of here. So this answer comes out to be negative 3. We're going to do the same thing for g of 0. G of 0 sets up to be the integral from 2 to 0 of f of t dt. But again, look at what's happening here with the integral. I'll need to flip-flop it to make this from 0 to 2 and put a negative out in front. So then from 0 to 2, I'm looking for this area right in here. So this comes out to be negative 2, which is positive 2. And now I need to find g of 4. So g of 4 is going to be the integral from 2 to 4. Oh, look, this time I don't need to change anything. I'm going from 2 to 4 right here from 2 to 4, and it's a positive direction. The integral is set up correctly, so I don't need to change these, flip-flop the bounds on it, so we'll just leave it at that. But from 2 to 4, that means I'm looking for the area right in here, which we already said is negative the 4 minus the pi over 2. And all these okay, so let's just go ahead and move on to part B, and it says find the intervals on which g is increasing. Well, for it to be increasing, I need f of t, which is the derivative of it, to be above the axes. Because what I'm looking for is the positive slopes, and these are the slopes. This is the graph of the derivative, which are the slopes in this case. So I'm looking for it to be above the axes. Well, where does this occur? This occurs, so in other words, let me write it here. We're looking for positive slopes. So this occurs from here, from negative 5 to there, it's above the axes, and then from 5 over here to 8. Because this only goes out to 8. So from here to here, and then from there to there. So let's go ahead and write this. So this occurs from negative 5 to 0, union 5 to 8. That's where the function is increasing. Okay, moving on to part C. Slide this up just a little bit more. And for part C, it says, find the intervals on which it's concave down, on which g is concave down. So now I need f prime of t to have the negative slopes, because this yields the g double prime of x. So where does it have negative slopes? Let's go ahead and take a look. How about from here, negative 2 to positive 2. That's a negative slope. This is flat. That's positive, positive. Here's my negative slope. These are positive slopes right in here. Then it changes, and these are all negative slopes right in there. Then positive slopes, positive slopes. So the only spots that occurs is from negative 2 to 2, and then it occurs again over here from 3 to 4. So let's go ahead and write that. So this happens from negative 2 to 2, union 3 to 4, where it's concave down. Now, you can look for inflection points at this point as well, because we're looking for where it changes concavity. So if it changes from a positive to a negative slope, that's a possible inflection point, and we'd have to test it. All right, moving on. So, right here, find all values of x on the open interval from negative 8 to 8 at which g attains a relative minimum or maximum, and then we need to justify our answer. So, what this is asking is we need this function f, which is g prime, to change. And we know that it's going to change from negative to positive at x equals negative 5. Let's take a look why at our graph here. It changes from negative to positive below the axes, above the axes at negative 5. It changes again at 0, above the axes, below the axes. Then it changes again at 5. Below the axes, above the axes. So there's 3 spots that it changes. So let's write that in over here. So it changes from negative to positive, negative 5. It changes from positive to negative at x equals 0. And it changes from negative to positive at 5. All right, so what does this tell us? Well, if it's changing from negative to positive, this is a relative minimum. If it's changing from positive to negative, this is going to be a relative maximum. And then if it changes again from negative to positive, we have another relative minimum. So our justification is because the slopes are changing, and we indicated it here. So we have a relative min at x equals -5 and 5, and a relative maximum at x equals 0. All right, here we go for the last part of this question. What is the absolute maximum value? I should have indicated here value of g on -8 to 8 and justify your answer. So I want you to write in value there because I want you to find the actual value. So we have to test. So we need to test our critical points and compare to the whole thing. So what this means is we have to find out at x equals -5. That means we're looking for the integral from 2 to -5, and we've already done that in the first problem. We ended up with -3. We had x equals 5. We did that in the first problem as well, from 2 to 5. Actually, did we do that one in the first problem from 2 to 5? We did not. So let's go ahead and do that one. So for this one, we are looking at the region from 2 to 5. So that's going to be -1 plus 1 minus the 2 pi. So again, I'm looking from the region from 2 to 5. So from right here, 2 to 5. So that's what we end up with. Okay, and these are minimums. Okay, for the maximums, we had at x equals 0, so we're going to test from the integral from 2 to 0, which we changed to be -0 to 2, and then we ended up with 2. And then I shouldn't have boxed that. Okay, so then we have to test for an absolute, and so that means we need to test the endpoints. We have to test the endpoints. So we're looking to test the integral from 2 to 8 and the integral from 2 to -8. So this one comes out to be, when we look at our graph and find the areas underneath, this will be pi over 2 minus 4 plus the -1 plus 9/4 pi. This one ends up being -2 plus 5 minus 1 minus the 4. So you get an answer here of approximately 3.64. I'm skipping a couple steps just to get to the answer. And you get an answer here of 2. So, comparing everything we have, all these values that we found, we can conclude that the absolute occurs at x equals 8 with a value of 3.64. This is the absolute maximum. These gave me minimums, so I threw them out. These two gave me maximums. I tested this one, but then I also tested the endpoint right here. And the endpoint gave me this from 2 to 8, gave me this value. From 2 to -8, gave me that value. And then from 0 to 2, which was my relative, was 2. Taking the largest of the three values, this was it, and it occurred at x equals 8, which was an endpoint. So that is how we find the absolute maximum of this function. All right, hope that helped, and good luck studying. I just realized something, guys. Right here, this is an error, so let's go ahead and fix that, and that should end up being at of -5 plus pi over 2, but it doesn't impact our answer because these are minimums anyway, and I'm asked to find a maximum value. All right, sorry about that.